Hi, welcome to the fourth tutorial in the Python Millionaire Retirement Simulator tutorial series. That's a mouthful. So if you stuck with me this far, you've seen 1, 2, and 3 where we built the bones. We added the interest rate, a fixed one. Then we got a variable distribution of interest rates in a Gaussian. And then we did the appendix to that where we made this set of plots here that were a Gaussian distribution. Kind of just proving that we actually have the distribution that we want. And so we're going to make that a little bit smaller. And now what we're going to do is try to invoke some actual data from market rates. And to do that, we need to find a source of historical data. So I've already kind of looked at the internet and found some websites. I'll put the links here in the description below. But you'll see we have either a Dow Jones 100-year historical chart. Here's an S&P historical annual returns. And so I've taken the liberty of taking this data, and it comes here in this chart fashion. And all we want is the year and the annual change in percent, right? That's the annual market rate that we're told about so often. And all this other data validates what's going on here. But you can see that the data in this particular case for the Dow Jones start from 1915 and go all the way to 2021. And so I have taken those numbers and I have put them into a file here. So we have this one here is for the S&P. Here are the Dow market returns. I've gotten rid of all the data except for the year. I have a comma to separate, and then I have the market rate. And you can notice that this number is 14.13, meaning 14.13%. So when we take this number and digest it in our program, we're going to need to divide that number by 100. Similarly, over here we have the year and a return. So 20% return for the S&P 500, 14% return for the Dow. And so we could use either set of data, and I'm going to put both sets of data as copy and pastable data in the description. So hopefully you should be able to, select all of this data from the description, copy it, paste it into your own text file, save it as, Dow market returns in your Python work folder, and we'll be able to work from it there. Again, if I go back to, just using text editor and the whatever you call this, the terminal, I can run my Python simulator. If I hit enter, yeah, it might actually run eventually, and it should pop up with the image that we plotted in our last one. So it may be that there's something that's stuck about it because I actually have the Spider terminal open and I've run it, but I don't think so. I think that it's just going to surprise me with a plot here at some point when I don't want to. So I'm going to see if I can't. Okay, we'll try that. Yeah, I'm having a little bit of difficulty here. A little bit of a slow. There we go. Okay, so there it is. The nice thing about using the terminal is that now I have, if I put this in the right spot, you can see at the bottom this number down there that is changing, and I can go to the central value here and see that it's 0.062%. So this bin covers the mean value of 7%, which is expected, and you can see there's about 275 entries in this bin. But yeah, this is giving that bell-shaped curve that we wanted to validate that we're actually having a good Gaussian distribution. We have some negative returns and some positive returns. But now we're going to do away with that in lieu of data. And so if you copy and paste those files and give them the names that I recommend giving, which are, I think, we're going to call them, I guess, years market returns. You could call it S&P market returns or Dow market returns. Something, as long as there's no forbidden characters in the file names, and then give them a .txt extension. Then you should be able to follow along. And I'm going to go back to Spider here. So what we're going to do now is we're just going to, anywhere above our while loop, we can go up here. We're going to invoke a file name. So file name equals, we'll use the DAO underscore market underscore return dot txt. And then we're going to open this file. So we're going to do f equals open file name for not writing but reading. Okay, so that opens the file for reading. Then we want to read in the lines from the file. Lines equals f dot read lines, open close parenthesis. And then finally we'll close the file. F dot close, open close parenthesis. So we've made the file name, we've opened the file, read the lines, and closed the file. So we have this variable lines now. That's a list of lines. So now we want to get the data, and if we can recall what it looks like, it's just two numbers, a year and the return. So to get those numbers out, we want to make two columns. Years equals empty list, and rates equals empty list. And then we'll say for line and lines, and we should be tabbed out in our thing. And we can do this fancy thing where we say year, comma, rate, singular, equals line dot split, and we have to use a comma as our split character. And so this makes two variables, year and rate. It assumes the form of our file, but that should be the same as the form that we've made. Then we'll want to say years dot append, and we want to make sure that we have an integer for year. And we'll say rates dot append, and we want to float for rate. And remember, we want to take this floating rate and divide it by 100, which we can go ahead and do on the fly as we add it to our list of rates. Okay, so now instead of having this mean and sigma and annual interest rate from a random Gaussian, our annual interest rate can be something where we sample from our list of rates. So now instead we can say, we'll copy this and we'll say annual interest rate equals random dot sample rates with an S. Okay, and that'll be the new way. And so this is actually just going to take historical data. Now you might not like to take the exact historical data numbers, and we're going to work around, or not work around that, but we'll work through that. But in this particular instance, we're going to just take the sample rates. So everywhere where we were getting the annual interest rate using random.gauss, we're going to comment that out, and instead we'll do the annual interest rate as a random sample of the list of rates. The paycheck interest rate will just be calculated in the exact same way it was before, and everything else should be the same. So now we're sampling actual historic market data for the Dow Jones Industrial Average from 100 plus years of data. So we'll hit save, and hopefully there's no errors, and we will run this. We do have an error. There's no such file in Dow market return, and that's because it's probably returns with an S. Yes, okay. So anybody, this could happen to anybody. It happens a lot to me because of the nature of my brain. All right, we added that S there, and now we're going to run it. It says sample missing okay, and that's, I invoked the idea of sampling from the list. Really what I want to do is choice, and we want to do that in both places. So sample from the list uses it can take multiple samples and creates a new list where the sample size is whatever you tell it. So you would say sample, the list name, and the number of samples you want to take. I only want to take one sample, and so that's called random.choice. So forgive me for mixing those two up. Hopefully now this should work. Okay, it did work. So here are our rates, These were actual market rates. Wow, we picked a year that had a 43% return. That was a great year. But then we followed it up with a year that had a minus 21% return. So, and we're ending up with 83,813, which if we scroll way back, 73,000. It's actually kind of in line with what we expect. It's not. Here's one that was 83,000 also. So, yeah. It looks like our Gaussian distribution was actually a fair choice, and to sort of demonstrate this now, instead of the test that we did previously, which we've continued to do by mistake, I just didn't omit it. Now instead of having this list here that we created of annual interest rates using the random.gauss, we're just going to instead of plotting this list that I created here, we'll just plot the list that I made earlier called rates. And this won't be as big of a list, but it should still have the same character that we were looking for before. So we may have to do something fancier to it, but if I hit save and I run this, hopefully everything works fine. Okay, so let's blow this up a little bit. So here's our list of rates, and it is not quite so symmetric as our other ones. It's kind of heavy-sided on the negative side, although it extends highly up to the 0.8 range. And so we may find that if we do something where we limit the range, we can say comma range equals, we have open close parentheses, and we would say maybe we'll say minus 0.45 to plus 0.55. No, we don't need the plus. All right, so we've added a range there, and we're going to run that and see if that changes how the distribution looks. It doesn't change any of the data, but it may change how it's plotted. And if it does, we will see it. It does change how it's plotted a little bit. So this is a slightly more symmetric looking thing, and you can see that there's some kind of gap here. This is where I guess the plot cuts off. So we're in this plot, we're excluding some of the highest end data where there's a singular entry of 80% market return for some year. But again, this is giving that general shape with very low statistics of the bell curve or a Gaussian that we've been invoking this whole time. So thanks for watching. This time, I hope that if you followed along, we've introduced the idea of having actual market historical data to supply our model with some realistic data. And so the next step is going to be to actually fit this data. And so we're doing a little more scientific computing. We're going to fit the market data and create an actual Gaussian that's a good fit to it. And once we've done that, we can, instead of using the actual historic data, we can use something close to the historic data. We can use other methods to make a more random but still historically reliable picture of the data that we want to use. Hopefully you've been following along. If you haven't, put some question or comment down below, and maybe I'll change or redo this series at some point and answer some of those questions. But thanks for watching, sticking in there so far, and I hope you have a great day. We'll see you in the next one.